Now, how do we factor quadratics? A quadratic is any expression that's in the form a times x squared plus b times x plus c, where a, b, and c are just numbers. What we want to do is be able to break these down into their smallest pieces. However, this is going to take a little more work than before because we aren't going to have really anything in common. Specifically, there aren't any x's that we can pull out of all three terms because of this c. What we need to do is look for two numbers, specifically two numbers that we'll call r and s, that add up to b and that multiply to equal a times c. We'll do an example of this in just a second. What we can do with those numbers is rewrite this. Instead of ax squared plus bx plus c, we can write it as ax squared plus rx plus sx plus c, and we know that that works because r plus s is still b, so we haven't actually changed the equation. And then because r times s is a times c, we should be able to factor the first two terms and the second two terms in such a way that everything matches really nicely. Now these steps sound kind of confusing, so let's jump into a couple examples. Let's say we're looking at x squared minus 5x plus 6. I'm going to go ahead and write this as 1x squared minus 5x plus 6, so we can see that a equals 1, b is negative 5, got to be aware of that minus sign, and c equals 6. We are looking for two numbers, r and s, that multiply to equal a times c, r times s equals 6, and that add r times s to be b, minus 5. So two numbers that multiply to equal 6, that add to equal minus 5. Fortunately, there aren't all that many numbers that multiply to equal 6. We could look at 6 and 1 and 2 and 3, but none of that's going to be helpful because we need this to be negative. So we could look at things like minus 6 and minus 1. That adds up to minus 7. That's close. Minus 2 and minus 3. That adds up to equal minus 5. Hey, that's what we want. So we are going to set r equals minus 2 and s equals minus 3. Next, we're going to rewrite this expression starting with ax squared, and then instead of minus 5x, we're going to write it as minus 2x and minus 3x. And we'll leave the plus 6 as is. We'll notice that if we combine these middle two terms, this is exactly the same as the expression we started with, so we haven't actually changed anything. What we have done, however, is made this expression into two terms, 1 and 2, that we should be able to factor. Let's look at these first two. Is there anything we can pull out of x squared minus 2x? Well, the only thing I can see there is an x. So we can write this as x times x minus 2. Again, we can verify that that does in fact equal x squared minus 2x if we were to distribute again. Now, for this second term, minus 3x plus 6, we could choose to pull out a 3. However, I'm going to suggest we pull out a negative 3 specifically so that we get minus 3 times, and then what's left over? Well, minus 3 pulled out of minus 3x, that just leaves an x, and minus 3 pulled out of 6 gives us minus 2. I did that on purpose, pulling out a minus 3 instead of a positive 3, because I really wanted these two terms to match. And since they match, we have something times x minus 2 plus something else times x minus 2 again. That means we can factor out an x minus 2. That leaves us with x minus 2 times whatever's left over, well, that's just an x, and minus 3. If you want to verify that this works, go ahead and use FOIL to distribute this, but you'll find that the thing that you get is exactly x squared minus 5x plus 6. Go ahead and pause the video and try for yourself. Let's try one more example. This time a equals 2, b equals 9, c equals minus 5. Again, we're looking for two numbers, r and s, where r times s equals a times c, that's negative 10, and r plus s equals 9. Once again, we can write out factors of minus 10. In this case, we'll have minus 1 and 10, minus 2 and 5, but hold up, we can actually stop right at that first one. Minus 1 plus 10 is indeed 9. So let's go ahead and write that in. R is 10, and S is minus 1. And then we're going to go ahead and rewrite this expression where it's exactly the same as before. We still have a 2x squared, and we still have a minus 5. But instead of plus 9x, we're going to write plus 10x minus 1x. Again, the reason for doing this is now we can factor the first two terms, and we can factor the second two terms, and we should get something that we can factor out of both of them. Let's give this a shot. What can we factor out of 2x squared and 10x? Well, I'm noticing that they have a 2 in common, and they have an x in common. If we pull a 2x squared out of 2x, we're just getting x. If we pull a 2x squared out of 10x, we're getting 5. And now this next one's trickier. Minus 1x minus 5. Doesn't look like there's a lot that we can pull out of this, but we know that we want to get something like this, something like x plus 5, and we can see, hey, let's pull out a minus 1. If we pull a minus 1 out of minus 1x minus 5, we get x plus 5, just like we wanted. And since we set it up so we have two terms that are the same, we can factor that term out of the entire expression, giving us x plus 5 times whatever's left over, in this case 2x minus 1. Once again, you can verify using FOIL that this expression indeed distributes to get the same expression that we started with. Let's do one more example. A equals 12, B equals 19, C equals 4. I'm going to keep writing this out, R and S. You don't actually have to write this out. We're looking for two numbers that multiply to equal 12 times 4, that's 48, that add to equal 19. 48 has a lot of factors, so let's see what we can do here. 1 times 48, that adds up to 49. 2 times 24, that adds up to 26. 3 times 16, hey, that adds up to 19. And so we can set one of these equal to 3 and one of these equal to 16. Let's go ahead and rewrite our original expression. We'll write it as 12x squared, and then remember, instead of 19x, we'll split it up into 3x plus 16x, so that we haven't actually changed the expression. And then we'll go ahead and factor our first two terms and our last two terms. 12x squared plus 3x, well, we can certainly pull a 3 out of both of these, and we can pull an x out of both of these. So let's write this as 3x times whatever is left over, in this case 4x plus 1. And then when we have 16x plus 4, the only thing we can pull out of both of these terms is just going to be a 4, leaving us once again with 4x plus 1. Since we set this up so that we have a 4x plus 1 in both of our terms, we can go ahead and factor out that 4x plus 1, leaving us with 3x and 4. That's It's 3x plus 4. Now what would happen if instead of r equals 3 and s equals 16, you had r equals 16 and s equals 3? Well, the math is still going to work out, although you might get a slightly different factorization. I encourage you to try this one for yourself.